So today's lecture is on DHCP, Dynamic Host Control Protocol. So DHCP assigns IP4 addresses and other network configuration information dynamically. Because desktop clients typically make up the bulk of network nodes, DHCP is extremely useful and time-saving for network administrators. A dedicated server is scalable and relatively easy to manage. However, in a small branch or a SOHO, a Cisco router can also be configured to provide these services. So Cisco iOS software supports an optional full-featured DHCP server. Now, the server dynamically assigns or leases an IP address from a pool of addresses for a limited period of time chosen by the server or until the client no longer needs the address. Now, this pool and all of the parameters of the pool are defined by us, the administrators, and it is us, the administrators, that actually go out there and create the pool. Clients will then lease the information from the server for an administratively defined period, again, decided by us. Administrators configure servers to set the leases to time out at different intervals. The lease is typically anywhere from 24 hours to a week or more. When the lease expires, the client must ask for another address, although the client is typically reassigned the same address. So the way that it works in a client-server mode. When a client communicates with a DHCP server, the server assigns or leases an IP4 address to that client. The client connects to the network with that leased IP4 address until the lease expires. The client must contact the server periodically to extend this lease. So in normal circumstances, just before the lease is about to expire, that device will start sending requests back to the server. This lease mechanism ensures that clients that move or power off do not keep addresses that are no longer needed. So again, when you're deciding how long to lease your information for, you definitely have to keep that in mind, because there are times when if somebody powers down, that's going to go right back in, or not that it's going to go back in, but if somebody powers off and they have that lease information, or if they're on vacation or something like that and they hold on to that lease information, that can be problematic. Because depending on the number of addresses that you assigned in your pool, say you assigned 10 addresses, and maybe 2 of those addresses are being utilized by people who are on vacation. That address is held while those people are on vacation when nobody else can utilize it. So it seems like it's, one of those little things like, yeah, so what else? But you kind of have to think in terminologies. And again, realistically, in the real world, we do private addressing, and there's so many addresses available to us on our internal network. But for connectivity outside, we know we have to have a public address. So you want to kind of decide, especially if you're a small business, and even though we've kind of gone away from traditional addressing where a Class C would be 254, now it's more assigned to, using VLSM as to what a company actually needs, you still have to kind of think about, in realistic terms, how many of your public IP addresses do you want to give up for DHCP services? And again, if you lease it for too long of a period, is that impeding someone else from utilizing the network within your organization? So when a lease does expire, however, the server returns the address to the pool where it can be reallocated as needed. So the steps to obtain a license. When the client boots up or wants to join a network, it begins a 4-step process. We refer to this process, your little cheat sheet, is Dora the Explorer. So the first thing that happens is a DHCP discover. So the message type is listed underneath in parentheses. So a discover simply says, hey, I would like to request an IP address. So that goes out as a broadcast. Now, in most organizations and in the real world, you do have more than one server within your organization. So this would be broadcast out to as many servers that are available. Next is the offer. So the offer is the server actually answering back to the client in a unicast form saying, I'm a server, here is an address offer. Now, sometimes you may get more than one offer if you have more than one server in your organization. Your device or the end device decides which one is the better offer to accept. Once they accept it, they send a DHCP request back to the server saying, I accept your terms. Again, going out as a broadcast. And then an acknowledgement, again going out as a unicast, is the server that you have requested the information from is going to send you a unicast message saying your acceptance is acknowledged and here is your information. So that is how the DORA request system works, with an end device gaining IP configurations from a server. Now, prior to the lease expiration, the client will begin a two-step process to renew the lease with the same DHCP server. So before the lease expires, the client again will send out a request. That request would be something to the form of, I would like to renew my license. It goes directly to the server that originally offered the information in the first place. If an acknowledgement, however, is not received within a specified amount of time, that client will then broadcast a request so that one of the other servers in the organization will acknowledge and give IP4 information. On receiving the request message, the server will verify the lease information by returning an acknowledgement. These messages, primarily the offer and the acknowledgement, can be sent as unicast or broadcast, as defined in RFC 2131. So now you have a basic understanding of how DHCP works and how it can make your job a little bit easier. So a router running Cisco iOS can be configured to act as a server. So when you're thinking server, don't think about the tremendously large black box that you would see in a normal production network, as in the the main distribution facility down the hall across from the restrooms. Okay, those are those big black boxes that hold multiple different servers. I can actually take one of my devices, i.e. a router, and turn that router into a DHCP server. So the Cisco iOS DHCP server will assign and manage IP addresses from specified pools that you define. So you're going to use the following steps to configure your router as a DHCP server. First thing you need to do is exclude IP4 addresses. So a single address or a range of addresses can be excluded by specifically the low address and the high address of ranges. So things you want to exclude are those addresses that are assigned to your routers, to your servers, to your printers, and other devices that have been or will be manually or statically assigned. You can also enter the command multiple times if you cannot do it in a contiguous order with the range command. So the command to do this is IP DHCP excluded address and low address to high address, or just each individual statement. Next thing you want to do is define a pool name. The command to do so is the IP DHCP pool and then the pool name. Now you want to make this name something that is meaningful. So in router on a stick, where you go out there and you create different VLANs off of your switch, those VLANs act just like LANs in a physical arrangement. So if you are going to use DHCP for all of those different VLAN subnets, then you need to define a pool for each one of those VLAN subnets. So you want to make that pool name, your first one that you would define would be DHCP pool VLAN 1, VLAN 2, VLAN 3. You want to make this name something that will identify to you. And you have to be very specific. When you are defining a pool name in DHCP, it is case sensitive. Okay, so So VLAN 1 written this way or written this way are two entirely different names. So it's not going to be bound to the parameters of your DHCP. So your DHCP would not work. So whatever you name your pool, you have to keep it consistent. Now, next thing you'll do is configure that pool once you figure out what it is. And again, noticing that when you type in IP DHCP pool in the pool name, you go into another router mode or configuration mode, as seen here. This tells you you are configuring a DHCP pool. Now, the address pool in the gateway router must be configured. You're going to use a network statement to define the range of available addresses. And you also have to define the subnet mask that goes along with it. And then you definitely need to exclude your router from that pool of addresses. And you do that by using the default router command to define the default gateway router. These commands and other optional commands are shown in the table on the following slide. So, defining the pool. Again, you choose the network as your command, and it's the network number and the mask or the prefix length if you're talking IPv6. Then you define the default router or gateway with the default router and then the address of your default gateway router. You also define your DNS server, define the domain name, define the duration of your lease, and if you'd like, you can also define the NetBIOS WINS server, which is your basic input-output system and is a program that allows applications on different computers to communicate within a local area network. So it kind of looks like this. And again, as you see here in this diagram, in this topology, I only have one router within this instance here. So in this example, I do have two separate networks. I have the 10 network and I have the 11 network. So I am going to create a DHCP pool for the 10 network. So first thing I do, again, is exclude those things that I want to be excluded. So I'm going to exclude the first 10 addresses. And if you look, to my configurations here, I'm excluding 1 through 9. Well, excluding 1 is really important because 1 is my default router, and 5 is my DNS server. So I exclude those two within this range from 1 to 9 so that they do not get thrown into the pool of available addresses. Very common mistake for students to forget about doing that. Okay? I also am going to exclude the very last address. Now, for different reasons, we've taught you that the very last address could be the administrator's address. It could be your printer's address. It could be something specific. So here I do my first range of addresses, excluding things like my default router and my DNS server. And then I do a single line to exclude a specific static address. Next, I choose the network that I'm going to allow that pool to grab from. Oh, I'm sorry, I skipped. Next, I'm going to define my pool. So in this scenario, I have two LANs, right? So going back to what you learned about your basic networking, I have two local area networks here. Coming off of here, I have LAN 1. Coming off of here, I have LAN 2. This DHCP has to do with LAN 1. Okay, this is who I am defining the pool for. So again, exclude who you need to exclude, whether it's a range or a single line or the combination thereof. Then define your pool. So my pool says this is a LAN pool for LAN 1. The network, for LAN 1 is right above you. Right, listed right here. This is my network number. So this is the network number in question, so you just write it verbatim what it is. It is 192, it is 168, it is 10.0, and my mask, based on that prefix, is 255.255.255.0, the first 24 bits, which is where your prefix comes from. Next, I define my default router. Next, I define my DNS server. Next, I define my domain name. Now, once you are done, you want to verify your information. So you can use your show running with your pipe command and the section of DHCP alone. It'll point you just directly to DHCP. I can do my show IP DHCP bindings. This will give you a list of all IP4 addresses to MAC address bindings that were provided by the service. I could also do show IP DHCP server statistics. This is going to display count information regarding the number of DHCP messages that have been sent and received. So to verify its operation, as shown in the example, do your show running config and the pipeline of section. Section specifically to DHCP, and all you see is you're not getting your entire show running, you are getting just the piece of show running that you are asking for. So if you're currently, again, as I've stated before, not using your pipe command, start using your pipe command. It's going to cut down on all of that scrolling that you're doing. So right here, this is where you want to verify that you have done the right thing. Check your range of excluded. Check your pool name. Check your network, your default router, your DNS, and your domain name. Domain name also has to match. Within your bindings, as shown in the example, the operation of DHCP can be verified using the binding command. This command displays a list of all IP4 address to MAC bindings that have been provided by that service. Excuse me. So you see the IP address, you see the hardware address, you see the lease time. It was automatic and it is currently active and active on gigabit 000. To see your statistics, the output of the statistics is used to verify that messages are actually being received and or sent. So if you're having an issue where your devices are not getting addressing information, you can choose your statistics to look at that will tell you whether or not things are actually trying to get information. So it's a very good troubleshooting tool. The command will display account information regarding the number of messages that have been sent and or received. So verify DHCP client has received it also. So you go into your individual PC, you do ipconfig /all. /all is needed. If you do your ipconfig, it will give you your IP address. But in order to see all the other parameters, you have to use the /all command. So because PC1 was connected to the network segment of 192.168.10.0, it automatically received a DNS suffix, an IP address, a subnet mask, a default gateway, and a server address, all from that pool. No DHCP specific router interface configuration is required. If a PC is connected to a network segment that is hosting the available pool, the PC will be able to obtain information directly from that router. If you want to disable the service for whatever reason, you would go in there and do no DHCP service. If you want to enable it again, you would just do service DHCP. Excuse me. Enabling the service has no effect whatsoever if the parameters have not been configured. So you have to configure your parameters. Now, clearing your bindings or stopping and starting the service may result in duplicate IP addresses being temporarily assigned. So do this if you need to, but like the terminology says, if it ain't broke, don't fix it. Now, in a complex hierarchical network, enterprise servers are usually located centrally. These servers may provide multiple different services, DHCP, DNS, TFTP, all of these different services for your network. Now, that could be all included on one server, or you could have what is referred to as a server farm, which is a separate subnet that would host all of your servers. Now, network clients are not typically on the same subnet as those servers. So in order to locate the servers and receive services, clients often use broadcast messages. Well, go back to what you know about your routers. Your routers do not forward broadcast messages. So in this figure below, PC1 is attempting to acquire an IP address from a server using a broadcast. Well, PC1 is over here. Okay, PC1 is over here. Oops, sorry. My server is over here on the other side of the router. So broadcast gets stopped here. So that request for DHCP information will not get received by the server. So R1 must be configured to relay a message to that server. So what I would need to do is I would go into the appropriate interface, in this example G000, and the command is IP helper address. So when you define the IP helper address, it is just the actual IP address without the subnet as you see here. Okay, no subnet address, I'm sorry. Yeah, no subnet mask needed. So again, as shown in the example, the interface R1 receiving the broadcast from PC1 is configured to relay that message to the server itself. So when R1 has been configured as a relay, it will accept the broadcast request from the client, and it will then forward that request as a unicast directly to the server. The network administrator can use the show IP interface command to verify that configuration. So right here, you'll see it come down. And here is your helper address. So again, if you put in a helper address or a relay command and your device still is not getting IP information, you want to do show interface and make sure that you actually put in the correct helper address. And in this case, it would be the address, excuse me, the actual address of the server itself. So other service broadcasts can get relayed. So DHCP is not the only service that the router can be configured to relay. By default, if you configure an IP helper address, it will forward the following 8 different UDP services. On port 37, time protocol. On port 49, attack act server. On port 53, DNS. On port 67 and 68, those are your DHCP and your boot P, which is the predecessor to DHCP. Port 69, TFTP. Ports 137 and 138 for that net BIOS. So automatically, just by putting that one command, if any of these come across the network, your router will forward them. Now, there are some scenarios where you might have access to a DHCP server through your ISP. In these instances, you can configure a Cisco router as a client. So sometimes Cisco routers in a small office or home office and branch sites have to be configured as clients in a similar manner to client computers. So the method used depends on the ISP. However, in the simplest configuration, the Ethernet interface is used to connect to a cable or a DSL modem. So to configure an Ethernet interface as a client, the command is IP address DHCP interface. So in this figure, we're going to assume that an ISP has been configured to provide services for customers with IP addresses from the 209.165.201.0 with a prefix of 27 network range. After the G001 interface is configured with the IP address DHCP command. So to configure your interface as a client, again, you're going to use the IP address DHCP. This configuration assumes that the ISP has been configured to provide customers with addressing information. So easy enough, you go into the interface in question, put in the IP address DHCP, do a no-shut. Excuse me. When I show my IP interface for that particular interface, it says my internet address is 209.165.201.12.27, and my broadcast is 255.255.255.255, and that this address was determined by DHCP. Now on your home routers are typically already set to receive IP4 addressing information automatically from your ISP. So this is so that customers can easily set up the router and connect to the internet. So for example, in this figure, it shows the default WAN setup page for a packet tracer wireless router. The internet connection type is set to automatic configuration, which is DHCP. This selection is used when the router is connected to a DSL or a cable modem and acts as a DHCP client, requesting an IP address from the ISP. Various manufacturers of home routers will have a similar setup. So, DHCP, pretty straightforward. Things you have to pay attention to though, because it is precise with the name and different things that you have to exclude and not put them into the pool where they could get grabbed by somebody else for utilization. So you do have to pay attention. Configurations aren't that difficult, but you do have to pay attention to what you are doing.